Okay, so again, we're looking at similar triangles, and what we're talking about here, we're just looking at a slightly different type of question that you can be asked as well. And again, it's just important. It's important then to use your knowledge of similar triangles. So if we look at the two of them here, we can see how a triangle is. We can represent a triangle like this. We can just represent it A, B, C. So each A, B, and C, it represents a point on the triangle. So for example, a triangle has 3 points. So there's point A, there's point B, and there's point C. So that's that triangle. And then we have this triangle here, EFG. Again, it has 3 points. So you have point E, you have point F, and then you have point G as well. Okay, so EFG. So there are two triangles. Now the question, it asks you to show that triangle ABC is similar to a triangle EFG, and find the length of the side FG. So notice the way a side can be represented like so, where you have these closed brackets and then FG. So this represents a line segment, or just a part of a line. So the line is FG. Okay, so we're talking about this line from here to here. Okay, so we want to find the length of this line. And notice also as well that we're given the length of some of the sizes. Okay, so we have a small triangle and then a bigger triangle. Now, what it's asking you to do is to show that the triangle ABC is a similar triangle to EF and G. Okay, so what we want to show is that the angles of both triangles are the same, okay, and that they correspond with each other. We can see, looking at this, okay, so there's a correspondence between this angle and this angle, okay, but we don't know what this angle is, or we don't know what this angle is up here. So we have to try and work them out. So let's focus first on the first triangle, so the smaller triangle, and I'll just write down as small, and then just this symbol here just to represent that we're dealing with the small triangle. So how can we figure out what this angle is in here? We know that for any triangle, all of the angles have to add up to 180 degrees. So therefore, we can try and work out what this angle is in here, this unknown angle. Okay, so in order to work out that angle, we know that, and let's just call it, let's say the angle, we'll just call it A for now, okay? So in order to work out the angle A, we know that it's going to be, the whole lot should add up to 180 degrees. So it's going to be 80 plus 43 minus 180, and then that'll give us the internal angle, okay? So you're going to have, and we can write it like this. We can write it like this. So the angle, and it kind of looks like a lopsided L, ABC, so that means that angle there. Or should I say it should be ACB, like so. Okay, so that represents the angle. So when the angle is written like that, so notice the way that you have A represents that A, C represents that C, and B represents that B. So notice that the angle in here is always the letter that represents the point. This point here that's on the angle is always in the middle between these two. Okay, so this is the angle ABC. So what's that going to be equal to? Well, it's going to be equal to 180 degrees. So 180, like when the three angles in the triangle have to add up to 180, minus 80. Okay, so minus 80. So you're going to have to minus 80 degrees. So that's equal to, let's say, 100. so that's minus in this angle, and then we want to minus this angle, and it's 100 minus 43 degrees, which is going to be equal to 57 degrees. So it's 57 degrees. So we've worked out here that this angle in here is 57 degrees. Okay, so 57 degrees. And we can see now as well that this angle and this angle they correspond with each other. Okay, or they are the same. Okay, so this further strengthens the idea that these are similar triangles. So now the last thing we want to do is we want to work out this triangle up here. Now we would expect, if they're similar triangles, that this angle up here is going to be 43 degrees. It'll be, if it is a similar triangle, but we have to work that out. Okay, so we can say then that the angle, and I'm just going to do it in a different color here and push this up a bit, so that the angle FEG is equal. Now notice again, so this is just a way that we can represent an angle. Okay, and notice that the E, okay, the point that's in the middle here that the angle is on, is in the middle between the two letters, between this letter and this letter. So that forms this angle here. Okay, and that's just a way to represent. All this is doing is just representing this angle here. And we want to, so how do we figure out what that is? Again, so all of the angles added up is going to add up to 180 degrees. So now what we want to do is we want to subtract these two angles from it. So it's 180 minus 80. Okay, that's going to be equal to 100. So that's, you just subtracted this angle. And now we want to subtract this angle from what's remaining. So 100 minus 57. And that's going to be equal to 43. So we know now that this angle up here is 43 degrees. So it's 43 degrees like so. So now, so this really kind of answers the first part of the question. So we can see that since each triangle has angles measuring 80, 57 and 43, so we can see these in both triangles, we can say that these triangles are similar. Okay, so that's the answer to the first question. So let's say answer part 1. We can say that since so since each triangle has the same angles, or we can say these are similar triangles. So they're similar triangles, okay? So that's that first part of that question. And the second part of the question then, it asks you to find the length of here and here. So this is, what we need to do now is we need to figure out what's the correspondence. So remember, with similar triangles, there'll be, so the angles are the same, but then there's going to be this correspondence that we talked about before. There'll be a correspondence between the sides. So for example, this side corresponds with this side corresponds with this side, and this side corresponds with this side. So we have to try and figure out what is the correspondence, like what's the link between these two. So there is a link between them, and we want to figure out what the link is. Now in order to do that, we need to have two corresponding lines, okay, or two corresponding sides of the triangle that have dimensions in it. So we can see here that this side and this side, it gives the dimensions. So this is 6 centimeters and this is 15 centimeters. And we want to work out like what's the correspondence. So we can see at a glance, we can see that this triangle is bigger than this triangle. So therefore the correspondence between this line and this line is going to be that this line here is bigger. But we want to quantify that and figure out how much bigger. So what we can do is in order to find out how much bigger, we can divide this side by this side, and that will give us the correspondence. Okay, so this is part 2 of the question. So we want to work out the correspondence. Is going to be equal to, so it's 15 divided by 6. So we can see that the correspondence, so 6 divides into 15, it goes 2.5, or 2.5 times. So what does that mean? It means that the correspondence between the sides of these similar triangles is that the bigger side, or the bigger triangle sides are 2.5 times bigger than the smaller triangle sides. And that's going to hold true for all the sides. This correspondence here, this will hold true for for each of the sides in relation to each other, each of the corresponding sides in relation to each other. So, so for example, this side, this side on the small triangle is 6. Therefore, its corresponding size is going to be 2.5 times bigger, and 2.5 times 6 is 15 centimeters. So it's 2.5 times bigger. So that this relationship will hold true then for the rest of the triangle as well. Now the question asks you to work out what is the correspondence, or sorry, what's the size of this angle here, so FG. So in order to work that out then, we say that the angle F, or the line should I say, FG, or the side even, the side FG is going to be equal to, so it's going to be 2.5 times the size of its corresponding side on the smaller triangle. So it's going to be 5 centimeters multiplied by 2.5, which is going to be equal to 12.5 centimeters. So 12.5 centimeters. So what? So this is this. So what we have found out then is that FG, or this side here of the bigger triangle, its size is 12.5 centimeters. And that's the answer to part 2. So we can see that this correspondence that we have discovered here, so for example, this side here is 2.5 times the size of this smaller triangle side, and then the same correspondence is holding true here as well. So this line, so this is 5 centimeters, and then this line is going to be 2.5 times bigger, so it's going to be 12.5 centimeters. So that's it really. That's like another kind of type of question that you could be asked as well. But the main thing is understanding what we mean by similar triangles, and understanding that in similar triangles the angles are the same, and then there's also going to be a correspondence between the corresponding sides as well. Okay, hopefully that helps.